Thank you so much for that. I don't know why my sound effects literally stopped working.
Oh, there it is. All right, it actually stopped working. Perfect.
Yeah, there you go. Let me go back to this here mix. So, yeah, we're going to be talking about getting started with Azure Cognitive Service, and then I might, if we have a little bit more time and everyone's interested, I might even show like the more advanced stuff very briefly, if that's okay, because I want people to get a sense for what I think AI is and how machine learning in particular, what it all means. And like I was telling Gregory, I bought myself a Wacom tablet because I needed it to work from home, and so I'm going to be using it extensively today. Let's see if it, oh, is it not working? Oh, there you go.
Oh, yeah.
Look at that. And I programmed these buttons here so that when I go forward, I could just use this Wacom tablet as a glorified like clicker. This is Yeah. The other thing that's important to me is if you have any questions or you want to know more about something, just literally just stop me. I'm not afraid to be like, I don't know the answer to that. I can figure it out. But this is more for you all. I mean, there's not a lot of us here. There's like what, 18, where so everyone can ask me something. I went full New Yorker. And feel free to just stop me and we can dive into something that you feel is more important. I do have a set content that's helpful. But just out of curiosity, there's like a raise your hand feature. How many of you all know or do stuff with AI at all? This is a raise a hand thing. I'm looking over at my screen's over here.
You got the raise a hand feature.
You do. It's at the top, not where it says leave. Don't click the red one, but to the left and to the left and to there's like a little hand. How many of you have been doing AI things? Out of curiosity, or put it in the chat or something because I'm curious. Okay, there's a couple of you all. So what I'll do then is since there's not a lot, I am going to literally start with like the whole like from start to finish kind of thing. Because the reality of the matter is when anybody talks about like AI, it's always like so it's really you can do AI in two easy steps. The first, obviously, is to start thinking about what you want to do with AI. And then step number two is fill in all the details. And I feel like this is like the presentation that we get all the time when it comes to AI, and everyone's like, you should be using AI, but no one really quite explains what it is and why. And so I'm going to do that here so that then we can get a sense for the landscape. So once I had an understanding of how to think about these things, then everything kind of just made sense for me moving forward. Because the reality of the matter is, and I want to make sure that you know this, and this is important. The reality is that AI is nothing more than a function that was lazily written with data. That was the news break here for this. That's all it is. It's just a fun. Did you like that one? I didn't want to spill that one too soon, but I think I already used it. Newsflash: AI is a glorified way of writing functions with data. That's it. It has no feelings, no emotions. It doesn't care about anything. It's literally just like a function. And we're going to actually look inside of one, if that's okay. And you'll be able to see it. And I got to make sure because for this demo, I need another camera, which is crazy. And I need to set it up here. Okay, here we go. Perfect. Hopefully it works. All right. The reality also is that there was a little survey on CNBC, right? It turns out that 40% of AI startups in Europe have almost nothing to do with AI. Because as everybody knows, if you want the VC money, you got to say AI and maybe even blockchain if you want the real VC money. And so this is kind of sad. So let's talk a little bit about what it is anyways, because if you were to think of AI as this huge bubble, and maybe I shouldn't use the term bubble when I'm giving a tech talk, because I feel like that's... So imagine AI as this huge bubble. It actually encompasses a lot more stuff. And the reality of the matter is that this started all the way back in the 1950s. So it's not like it looks like 80s, but it's literally 50s. So this was a long time ago that this started. And if you like to think of AI, I like to think of AI as a glorified way of making a function. And AI back then was literally a glorified search. And you probably played like checkers or chess, right? It uses some variant of an algorithm called Minimax, for example, which is a glorified search, or A star, which is an intelligent search for finding answers. These algorithms basically found a way to restrict the search space and intelligently find how to get something. Like, for example, if you're driving your car and Waze is like, you should go this way instead of that way. Notice that it's a constrained problem because it won't let you drive through the woods, for example, in Portland. It won't be like, hey, you should like run through this fence and then go through because there's basically a very fixed way. And A star is a really cool algorithm that looks at the entire world as a bunch of edges and nodes, and you want to get from one node to another node, and the A star part is the heuristic function that tells you which edge you should go on, and it's you could fit almost a ton of problems with that. Minimax is another way of solving these kinds of problems that feel AI-ish. Like, for example, tic-tac-toe, if you think about it, the way tic-tac-toe works is someone puts an X and you have to decide where to put the O. But if you look at it, there's only 9 spots. So if you put an X somewhere, there's only 8 spots where they could put the O. So why not just create a big tree that says if I put my X here, they'll put all their O's here, and then go down another, down another. And it turns out that with modern computers, you can actually search the entire space, right? And Minimax is an algorithm that says if I do this and they do that and I do this and they do that, pick the best path through that, and you can basically solve a lot of problems. It turns out that there were certain problems where the search space started to become a little larger, and that was a problem. Like, for example, tell me what's in this picture. Like, there's no way you can create a search algorithm to do that. I mean, it's really hard. And so there's a class of machine learning algorithms that are super cool that we've all heard about, like decision trees or naive Bayes, for example, which are basically algorithms to produce algorithms. Oh, wait, hold on. I made a mistake. Oh my gosh. Escape. Escape. Sorry. I try to abort, but it didn't work. Okay. So naive Bayes, and then we have others like support vector machines, for example. Man, I am having like tons of fails today with the stuff I was supposed to like really. No, don't anyone tell my significant other this doesn't work because I paid for this, right? Naive Bayes, and then things like SVMs, for example. And what they did is they were ways, or neural networks, for example. And these were ways of creating compact representations of the space in a way that you would instead give it examples of things and it would produce an algorithm for you. Now, deep learning is basically neural networks plus plus. Now, the meaning of deep, how deep these neural networks are, really depends on the marketing department. It could be up to 5 levels deep, and that would be deep enough for your particular marketing department. That's okay. But basically, it's a subclass. So you can see that as we go down, artificial intelligence really is a set of techniques to make machines look like they're being smart. Um, but then again, like you've written code that doesn't use neural networks that does smart things. Like, for example, the smell test is, can you do this with a lookup table? Is your AI really a glorified SQL query? Could be. So maybe let's do a story here, because I think a story will illustrate like when you should use it. So imagine some of you work at a bank. I don't know. There's always like one person that works at a bank, and I would like to apologize in advance because like working at a bank as an IT person is like the dirty jobs show. It's like the dirty jobs, not that it's not honest work, but that basically Fred keeps on putting like names in the age field, and because it's COBOL from 1960s, it just lets you do that, and you have to go and fix it. That's what I mean by dirty jobs, right? Like the database is basically a dirty job there. So imagine you work at a bank, and one day Bill comes down because he's from the marketing department. And he's like, hey, I have a really good idea. And you're Sally, obviously, the crack programmer there. And Bill's like, Sally, I have an idea for a super good program. Picture this. And when Bill from marketing comes, everyone's like, oh, great. So Bill's like, listen, what if, Because you know how right now, because it's an old bank, right? Right now, everyone has to go through the pictures of the checks and see if they're upside down or not. What if we wrote some AI to make sure it's right side up? So imagine that as a programmer. And you're like, okay, Sally is a crack engineer and she knows what she's doing. And because it's like a crappy bank, all of your checks have like a black stripe at the top. So Sally's like, yeah, sure, I'll totally use AI. But if you think about it as a programmer, you can basically sample 100 random pixels near the top of the image because let's just pretend they're cropped perfectly. And you would know whether it's upside down or not. So Sally figures this out in her head and she goes, yeah, it's gonna take about 8 hours a day for me to do it. And I'll get it to you tomorrow. Really, it's gonna take 4 hours, but it's a lot of YouTube to watch. I mean, if they're gonna make the content, someone's got to watch it. And so Bill's like, cool. And so the next day it's all done. And Bill's like, this is so cool. The owner of the bank, obviously, if you own a bank, you have to ride horses. I don't know what it is. It's just a rule, I guess. So the owner of the bank, she owns horses. And Bill's like, look, super good idea. Because only the bank owner has pictures of her horses on her checks. What if it's just this one thing? Anytime a marketing person tells a technical person it's just this one thing, um,
Run the other way, basically.
this is the general feeling when someone's like, it's just this one thing. No, it's not. Basically, it's just this one thing. Like it's just one button to launch something into outer space and land it. I mean, it's not. It's just one button. I mean, how hard can a button be, right? So Bill for marketing's like, what if, picture this. What if we let the owner of the bank use her picture on her check of her horse? Just this one thing, just for her. And you're like, ah. And you're like, well, fine, give me the JPEG. Give me 2 examples, right? And you're like, you're super good. You're like, it'll take 2 days. Really, it'll take one day. It's a lot of YouTube to watch. But basically, you figure out a really clever way of doing a lot of if and else statements because you know that the main is on this side, and if it's not, then it's the wrong thing. And you basically sample 100 random pixels, 100 pixels, fixed pixels, and then if it's not all aligned. It's an ugly code, but you write it and it's good. Okay. And then Bill comes down from marketing and says, she loved this so much, just this one thing. Now we want you to do it for any person, for any picture, for any check. Do you see what just happened there in your brain? All the VCs in Europe would have called the first two AI. But it is in that gap where all of a sudden you don't know how to program a thing where AI, specifically machine learning, fits the best. That's the smell. If all of a sudden you're like, I don't know how to code this, but I have a lot of examples of it, that's when you should use machine learning. Because programming is this thing, right? We have an algorithm that we write a series of steps and then we give it some input and then the magic happens in here, with the JVM bytecode, whatever you're using, because we don't care what you run on Azure. The slower the better. As we say, hourly billing sometimes, you know what I'm saying? And then out comes the answer. But machine learning flips this around so that instead you put the answers and the input in, and out comes an algorithm. But we have fancy terms for it in data science. This is called the data, and this is called the machine learning model. And you have options when it comes to these things, right? Because something has to happen in here in order for the model to be produced. And once you have this model, then you can use it like regular programming. Just like I said, machine learning is a lazy way of writing functions with data, which is awesome. And then out come the answers. So here are the options. Like just like right now, like you can either build your own, rent one, right, or modify one that already exists. Example: I used to work for DevExpress, and they built like data grids and stuff. And one time, because I was at the booth, and one time this dude came out. He's like, "Hey, I could write my own data grid." I'm like, "You sure can, but do you want to support it for the rest of your life?" And he was like, "Where's your material?" I'm like, "Yeah, of course. Any one of you folks here can write your own data grid." But you're not just writing it for that one project, you're writing it for the rest of your life, because you know you have everyone has code out there that they're still supporting that you may be embarrassed about, right? And the reality is you can either be in the business of making machine learning models, which is awesome because we need it, or you can be in the business of using them and be in the business of, well, whatever your business is. So option one is to use pre-built AI, and that's where cognitive services come in. Cognitive services are a comprehensive family of AI services and cognitive APIs to help you build intelligent applications. Right? That was the commercial. It's over. But we are doing computer vision, because that's what I promised everybody. And it turns out that they're basically like a bunch of APIs. Right? So let's go to vision. Let's go to computer vision. Right? And let me show you some of the stuff that we can do. Hold on, let me make sure that I didn't. I want to make sure that I gave you all the. Yes, so that's what I'm showing you right now. So I am on track. Here we go. So this is really cool, right? Because basically, we're just gonna like try it out right here. So what I'm gonna do is I'm gonna bring up a picture of something. Not rhinos. Let me go to my Twitter account. Let's get the tweet. Let me go to my profile here, and let's just open this up. Open image in new tab. Boom. Okay. So we're going to try this in the computer vision, because I can literally just put a URL in here and we can just try it out. Let's just analyze the image and see what happens. So notice that it would be really hard for you to program this, but it's really easy to call an API to do this. And notice that what it's found is there's a rectangle with a person in it. There's another rectangle with a person in it, and there's people in it. You can see that here's some tags. There's a person in there with his confidence. It's outdoorsy. Very nice. Yes. There's a tree in there. Someone is smiling. It's a human face. Maybe that my significant other is the person. I don't know what I am. There's a woman there posing with a suit, a man, and do you see what I'm saying? And if you want, maybe we can even caption it. Seth Juarez et al. Posing for the camera. Now, this is funny because it turns out there's this recognized celebrity thing. And I remember this was like the funniest joke for me. Look, it found me. It was a joke that I got to use on stage all the time. And I was with this really famous Microsoft person, whatever that means. And I took a picture of him and then I showed a demo, and it's like Harry Shum, who used to run all of MSR, and now he works somewhere else. Harry Shum and some random guy. It didn't say that. And then it was just so funny. And the devs must have been watching that. So they programmed me in. And so now Microsoft's computers recognize me as a celebrity.
Slow clap.
Yeah, I basically made it in life.
Nice.
Yeah. So that's in there. But the cool thing is, if you look at this, there is a lot that you can just get with this API. And there's a number of other APIs in there that you can use as well. And I didn't show them to you. Let's go back here. Vision. Let's do. I mean, there's computer vision. There's face detection. There's form recognizer, video indexer. Just a ton of cool things that you can literally just use, and you just call it. And I think like the first N,000 things are just free to try out, which is really cool. So, by the way, yes, you are learning from a celebrity. I am very famous at very specific people with like single digits of people. It's really cool. Very specific places, though. Very specific. And there's a ton of things that you can do. Obviously, I'm showing you just 3 here, but there's other things that you can do, like spatial analysis, image understanding, blah, 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 blah. Okay. So that is that for computer vision. There's other things that you can try out. Let me go back here. For example, with language understanding, it's cumulative speech, like speech to text, which is super cool. Like I trained it to talk like me, which is kind of creepy, but also amazing. Also amazing. And again, it's just AI that you can call instead of AI that you make, right? And so that's what this part is. using pre-built AI. That's what cognitive services is. But cognitive services also has a second part where you can actually customize things, the models, to make it a little bit easier to work with. And so that's what we are going to do in the second half. And then if we have time and everyone's not tired, I'll show you how to build like custom models in Azure briefly, right? Because I don't want to get into it too much. I can if you want me to, but I won't. So you can customize pre-built AI, and there's something called custom vision that lets you do that. We're gonna rock, paper, scissors this thing. So let me go to I'm gonna minimize this here. Let me bring this over here, and I am going to go to something called customvision.ai. I'm going to sign in here. Let me move this over because I don't want to make maybe there's something secret that I don't want to show you. Terms of service. That's all. So far, so far so good. Okay, loading my projects here. I have a lot of them. No, dang it! I'm in the wrong directory. So let me go here and open this up, and let me go to custom vision. I have so many accounts at this stuff that sometimes it's just like, here we go. That's the one I wanted. So custom vision is interesting because it lets you upload your own picture, and we're gonna do rock, paper, scissors. It lets you upload your own pictures and then classify them by either classes or object. And we're gonna do classification instead of object detection. Object detection gives you the bounding box. And so I built a handy dandy application here, code dot, get this up and running here. And basically, I'll get into the code as much or as little as you want me to. But let me just run it first so you can see what it's doing. So I'm going to go to the CD API. And then I always forget how to run these things. So we always go to the package.json here. Looks like npm start. So we'll npm start this one. And this is a backend basically for this app that I'm going to show you. And the code's all online, so you can totally, I'm not going to need the Wacom tablet just yet, right now. Cool, there's an Azure function that's running. Uh-oh. Well, I'll leave that there. Let's get the client to run, and then we'll figure this out because we're all friends here. CD vision, and then CD client. Let's go to less, and let's look at the package.json here. Serve, and this is yarn serve. So let's get this one going here. I'm starting the dev server here, and the client will work for sure. I don't know if the backend will work, but I'll show you what it's doing. That way you can see that like there's nothing up my sleeve here. So let's open this up and let me bring this over here and let me control V this localhost, and then let me move the microphone out of the way because you're probably wondering, well, how is he going to show this camera that he's showing? I have two cameras, which is this one here, Pro Cam, boom. And the idea is if I show it a rock, it should see rock. If I show it paper, it should see paper. And if I show it scissors, it should show it scissors. Is this working, right? How does it do that? It's crazy, right? Well, the reality is that I'm using this custom vision and I'm giving it a ton of pictures of the right thing, and then I'm telling it to train, which is really cool. Let me go see if I can get the backend started so we can give it some more data because let's see. Where did it fail at API? Let's see. Oh, this happens sometimes when I upgrade Azure functions. So what I'm gonna do is let's just cheat. Delete the whole thing and see if it works. If you have this error, by the way, I have been able to fix it this way. This is Azure Functions, by the way, in the background. I'm just gonna delete this. Let's delete all of them. Screw it. I mean, if it's not working, right? And then let me go here and let me try again. npm start. Let's see what happens. Here we go. Here we. Uh. Mm, uh. Ooh. Perfect. Now it's working. Like I fixed the thing during a user group. Isn't this awesome? Let me go back to this thing and let's see if there's places where it makes mistakes. Like that's clearly wrong. It's having a hard time here. So basically, I just need to give it a couple of more pictures like that. Let's find other things that it's getting wrong. Let's do a. Well, that looks like a rock, but scissors. Oh, right around here, it's having a hard time with scissors-ish. So I'll just give it a couple of images here, scissors. And then let's do rock. Here it's having a little bit of time with some rock. So let's get, oh, yeah, see? And then what I'm going to do is I'm literally just going to give it more training data. I'm not going to train it because it takes about 9 minutes to train. But basically, when I send this stuff over, there, it's gone. You'll see that now when I go to the training images, you'll see that these are the ones that I just submitted. And so I train it, and then boom, it's good again. So I'll hit train now. I'll do a quick training because it's going to take a little bit of time to do it. This is the one I trained it. I trained it 4 days ago to make sure it would work, and then I had an issue, so apologies for that. But basically, now I'm getting a computer to recognize rock, paper, and scissors based upon the pictures that I gave it to inside of Custom Vision. Because in Custom Vision, basically, we have really good models that then you can adapt on your own. So you're probably wondering, well, how did you build this? That's a really good question. In the API in the background, there's basically a function, an Azure function, that takes the pictures and gives it to Custom Vision because Custom Vision has an API. And so notice here, I'm literally just creating pictures from files and I'm pushing it to the Azure Custom Vision service. You can see trainer, create images from files, and that's it. But to go and train it, I could automate it further and retrain and do that kind of thing. This is called ML ops, the process of delivering value with machine learning. But on the client side, you're probably wondering how does it do that so fast? Right? Aren't you wondering like because it's like this is like sub-second recognition, right? How is it like are you calling an API? What are you doing, Seth, that's making it so fast? And is it one of these things where you're showing something that actually doesn't work, but you're just showing it because you're trying to be cool? No, this is actually the actual thing I'm using. I'm using this iteration because it turns out that with custom vision, so far as I know, cognitive services is one of the few things that lets you lift and shift down. We have something called container support where you can pull these cognitive services into your own on-premises location. Or look at this, it lets you literally export the model that it built. Which is really cool. I'm gonna download it and we're gonna look inside this model because we're gonna see once and for all what's inside of this.
I thought it's a black box.
What? We're gonna unblack box this son of a gun. Here, let me escape here. Of course, we're gonna keep the writings because they're gonna be one day they're gonna be worth like a couple of nickels. So here's the thing. I just downloaded the Onyx model. Where did it put those files? Did it like put up here? It put up here it is, and then it was this thing right here, and then it was this thing right here, and then it was this thing right here, right? So take a look at this. I'm gonna open this with Visual Studio Code so you can see basically the labels. That's part of the model. What else we got? There is this export manifest. Let's see what this looks like. Just basically looks like the output of the thing, right? And let's go to this manifest metadata. You can see like it talks a little bit about how it was built, right? And you're like, what? This basically explains to a person that knows machine learning how to put stuff into this model. And then we have the actual model itself. I'm going to click on it. And I want you to be ready because we're not sure what's going to happen. This is it.
It's a function.
Again, this is live footage of an actual machine learning model. And you're like, well, what is that inside of it? Here, let me show you what's going on. Basically, Custom Vision resizes all your images to 224 by 224, and you're probably wondering what the 3 is. It's the channels, red, green, and blue. PyTorch does channels first. I think they're using PyTorch, if I'm being honest, but I don't know. And basically in here, you're like, well, what is it that it learned? It learned basically a bunch of numbers to multiply your pictures by. That's it.
What?
Like literally, that's it. And you're probably wondering, well, how does it do that? Well, it turns out that it's actually quite long, and it multiplies all the pictures and does some things called convolutions. It does some normalization, but basically, there's a bunch of mathematical functions in here that the picture is passed through until it gets to the end. And at the end, you're seeing that the final thing is it multiplies. There's a matrix that comes in with 10, 24 inputs. It gets squozen down to 4 outputs. And basically the thing that comes out is this vector of size 4. And each one of those slots, a vector is like an array. Each one of those slots corresponds to the label, and the one that has the highest number is the one you guess. That's it. That's it. And you're like, wait, no, that can't be it. No, that's it. That's literally it for image classification. And you're probably, well, how is it that they have so many different kinds? Because it turns out that these things can be built in different ways. And you can create different versions. I think this looks like a ResNet to me. You can see the skip layers here. There's other ones like MobileNet, VGG. There's just basically different architectures of things. And the way that when you're training it, you basically have a function that measures how bad this is, and you use calculus to minimize the loss, which is a badness function. And so basically, all this neural network wants to do is please the data to make it so that it doesn't make any mistakes on it with calculus. That's it. Like, and I know this is like, you're probably like, well, but Seth, you did not answer the question of how is this thing still, oops, move the mic out of the way. How does this thing do this so fast on your browser? Because you haven't really answered that, Seth. Well, I will. Okay. Turns out that when it comes to things like software really isn't a real thing until there is a JavaScript version of things. And I can export this TensorFlow JS model. Beep, boop, 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 beep, boop, beep. Hold on. Is the new version out? The new version is out that I just trained. And I can export this as a TensorFlow JS model. Beep, boop, beep, boop, 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 boop. And this is with the new pictures in there, that were supposed to smooth over that issue, that the couple of issues that I had. So now I can basically download it. Show and download. Let's right click properties here. Unblock. Okay. Now what I'm going to do is I'm going to go over here to the client on the public, and looks like there's a model in there. Reveal in File Explorer. Yes, I will. I'm going to move this out the way over here. Boom. Oh, looks like I have already done that a couple of times. And now what I'm going to do is I'm going to take this download and put it into the model. Not the Onyx model. What am I doing? There's too many folders. Where are you? Here. TensorFlow JS, and we're just basically going to move it over. Oh, there's a new license file. We should look at that. I wonder what the license is now on this. So I'm going to move this over here. Boop. Well, let's look at the license here. Open with Visual Studio Code. Oh my goodness. This is new. But again, it's an awesome license. Right? MIT. And now that I have the new model in there, I can refresh. Looks like it did refresh. Refresh. And look at this. It says 120, right? Because it's tomorrow on our servers. And now basically I can go to this camera right here. And now we have this new model that, remember, it wasn't so good. Oh, is it still weird? Looks like I need to give it more data. But the more data you give it, the better it is, because it didn't do so well over here, but now it didn't. But now if I go down, there's problems. And then scissors, rock, and paper. And this is the model that I just uploaded. And if you're wondering, well, why is it so fast? It's basically because on the client, right? I have this, I did view. I did view because it was easier. Basically what's happened, yes, I know. It's a mono repo. Forgive me. So here we have a couple of things happening on this page. The first thing is that the model, well, let's start with the mounted. When the thing mounts, I basically get a reference to the canvas, and I enumerate the video input devices, and then I load the model. And this here set device tells you which device to use, and that's why I have multiple cameras. But basically, the load model loads the model, like on the client side, with TensorFlow.js. And then I do this set interval, which is every 100 milliseconds predict. And what is it that it does when it predicts? Well, it gets the rendered, it gets the image, it draws the image, and it sends this image to the model. And then it gets the prediction out. Remember how I said there's like a vector of size 4? I basically get the max index, and that's what I return. E times 100, which is the probability. And that's it. And this is happening every 100 milliseconds on the browser. That's cool, right? I mean, that's really cool. And right now you're thinking, wow, it's thinking. But here is the little dirty secret of AI. Let me pull up my iPad here. What does it think the iPad is? And so right now you're like, oh, it generalized and figured out that it was paper. No, it didn't. It didn't. It doesn't know anything. I could give it the picture. Here's my phone. It's a rock. And you're like, oh, because us humans, we're really funny. Like I could pick up a rock and draw a smiley face on it, and you'd be like, oh, it's happy. But it's not happy. It's a rock. And right now you're like, it thinks your phone is scissors, and in your brain you're trying to make an association with how it could be scissors. Or right now you're like, aha, it thinks the iPhone is a rock, right? But it actually doesn't. What's happening is the picture is getting multiplied by a bunch of numbers, and out comes a vector of size 4. And you're probably thinking, well, it's giving you these aren't even probabilities. There's just a mathematical function at the end of it called the softmax function, which forces it mathematically to sum to 1. And so it's not even a real like life probability. And so the problem is that this thing will learn with whatever data you give it, because all it wants to do is satisfy the loss function and the model function. And so if you train a model, and I'm gonna stop this because it's gonna start to hose my browser. If you train a model with pictures of, for example, only Caucasian people, you're gonna have a problem. And this is where the ethics of AI comes in. It's not that the robots will kill us, but it's that our data is almost always biased. And sometimes not biased in a mean way, right? Maybe it's just like you wow, you only your store only caters to middle-aged adults, right? That means that if a child walks into your store, your model is going to predict based upon the data set you gave it, and that's where the ethics in AI issues come up. Okay, so we did that. Cool. Now let's talk about custom AI, and then we'll wrap. My example for custom AI is. By the way, any more questions about the rock paper scissors? Because I want to make sure that I've answered everybody's questions.
Yeah, please. If anybody has questions, feel free to jump off mute. Ping them in the chat, whichever floats your boat.
Because I can go to custom AI, but it's involved, and I don't want to move forward until I got all of the questions about this answered. Everyone's like,
anybody? To your point, the ethics, though, Seth, I think I don't know if you've read the book, but Weapons of Math Destruction.
Totally, it's awesome.
Amazing
Absolutely.
book that talks about just why model learning and just it's all just about the data you give it. Is what you're going to get out of it, and so everything is inherently biased. I'm just dropping the link here for anybody who's interested in that.
Beyond that, there's a question. Even before you get to the data, you should think about, I'm going to do a machine learning model. Who could it harm? Who could it benefit in a disadvantageous way to someone else? Right? If you start with those questions, then you can look at your data with that in mind. But seriously, no more questions?
Any questions at all?
Hold on, let me get my sad music here while everyone doesn't.
I got a few up my sleeve if you don't think so.
That's too loud. That's my sad music, but it's too loud. Sorry, you're gonna go. Go ahead. Go ahead, Greg.
Yeah. So first off, like with the Onyx file, so is that like a typical type of file that you see when you're working with either just Azure Cognitive Services or AI in general for the models? Like for instance, data model files can be so many different things. Oh, it can be any of these type of.
Yes. So if you want to embed this into an iOS app, you can download the Core ML, right? Or the different. I think this does binning, right, to make sure it fits. But you can also export it in TensorFlow, and there's various flavors of it, right? If you're a machine learning person, you know the save model format, or TensorFlow Lite, or the full TensorFlow, or JS TensorFlow, which is what I did. Onyx is like the PDF of deep learning format, of machine learning formats. That's what it's trying to be, so that everyone can pass. Because once you have a format for machine learning models, then the hardware folks can start to optimize the heck out of it, right? Instead of having to support 1,000 different ways of storing these things, it can load these things up really fast and do the execution really fast. Onyx models are optimized in Windows, for example, and something we have a layer that works directly with DirectX to make Onyx models run super fast. So that's a cool thing about that. But there's a ton of them. You can a Docker file or Vision AI Dev Kit if you use that. But generally, the most ones that are used, the two most famous machine learning frameworks are TensorFlow and PyTorch. And PyTorch has native Onyx support for loading in them, so it's kind of cool. Okay. Any other questions?
Questions? Come on, people.
So the last thing I want to show you briefly is if you want to build your own AI models, I guess I can stop this one. I'll show you one here that I built locally for doing food AI. Let me close. I closed the other one. So code dot. You can see that this here is like an artisanal model. Like a free range artisanal cage free model that I built. You can see all the model files are over here. Having trouble hearing you. Isn't AI wonderful? Like my watch was like, I can't hear you. I'm not talking to you. Siri. By the way, I changed Siri's. Here's another interesting ethical question. Why are all the subservient AIs, why are they always women?
I saw an article on that pretty recently, actually.
Well, I changed mine to my fastidious butler. That's why you heard it. Because that's another thing. And all the smart AIs, like Watson, why do they have male names, right? And so you just need to think about these things.
Inherent bias.
Yes, and Scott's like in the UK, Siri's default voice is male because they find it better. Yes, yes. By the way, here is a model that I'm building. The data comes from over here. And you can see, like, for example, here's burritos and tacos. Here's my first burrito.
It looks like a delicious burrito. Just throw some sauce on it.
There's some ugly burritos, by the way. I just picked them. There's a way to download pictures from Bing. And basically what it does is there's these data sets. Let me go back to the training. there's data sets called image folder data sets, which look at the folder, and the subfolders are the names of the labels, right? And so tacos and burritos. And so this is the training data set. This is the validation data set, meaning to see if it's doing a good job. So when someone says they get 99% accuracy on their machine learning model, it means that they have a bunch of data and they hack like 20% of it off, and they train it on the 80%, and the accuracy is actually on the 20%, not on the entire set of all pictures of tacos and burritos in the universe. Remember that. And that's also important. And so there is the data that we suck in. This is the model, right here. There's two ways of describing models in PyTorch, right? You can do a class, or you can do it in line with the sequential. And so this is using MobileNet. So I'm basically stealing the weights or the numbers from a different model that was trained for something else with pictures. But because pictures are pictures are pictures, the lower layers kind of learn the same-ish kind of thing. And then I replace the bottom layers to match tacos or burritos. And so when you look at these machine learning models that it builds, here's the outputs. Let me find the one that says, there it is. So let me reveal this in File Explorer. And when I open this up, you're going to see that it's basically like the other thing I showed you, just not quite the same, right? Because it's using MobileNet. Maybe the other one looked like it was using MobileNet too. But you can see here it's the same thing. It's just that it's a different shape, and you can, like here, you can see in the actual code, right? 1,000 to 256. Do you see this right here? 1,000. Oh, let me zoom in. 1,000 to 256, right? And then you can see 256 to how many classes there are, right? Which are 2. So you can see that these matrices, GEM stands for generic matrix multiply. Yeah, I mean, you remember multiplying matrices in linear algebra. And so basically here, I'm telling it how to shape it, right? I didn't do the whole thing. I basically stole another one and then reshaped the last couple of layers. It's like chopping off the top of a bottle, just chopping off the top of the bottle where the label is and then slapping a new one on it. That's basically what I did. This is the loss function that tells us how crappy we are at it. This is the thing that optimizes the loss function to go to 0. And then you just loop through the data. That's it. Let's see if I can make it work here. And you're probably wondering, well, why are GPUs so important when it comes? Because multiplying matrices is basically what all the video games are doing. Like everything that's happening in your game is matrix multiplication, and so it happens really fast. And so that's why we like doing it here. So let me do Python train, and then you'll see that it'll basically just start up. That's a crazy long model. Sorry if I missed this, but can we train models in parallel? Yes. Yes. And the coolest bit about this is in Azure Machine Learning, you can actually create compute nodes or clusters to run these things. This is a compute cluster with 5 machines that basically will start running it on different machines, right? And the cool thing about Azure is that you can actually set the minimum number of nodes to 0, and if it idles for 5 minutes for 120 seconds, it'll just shut down the nodes. So if it has nothing to do, it won't do anything. And then, so this that you're seeing running here, this is the model, by the way. Yeah, it's really long. It's printing it out. It's running now. And then in a second, you're going to start to, there you go. So hopefully you'll see that the heat generated from my machine is going to be super cool because I can warm my hands by the fires of the GPU as it's like making the loss function go down, which is awesome. You can see it's super dumb at the beginning, but then it gets better. But the problem is, like, the question that Scott asked is, can we train models in parallel? Well, not on your local machine, but in the cloud you can, right? And you can see here, I got to cancel this because I don't want to do it. So there's a food AI experiment that I've already done here locally. Here's all the ones that completed. I've been running this locally a lot, but notice that I ran it November of last year. And you can actually inside of it just see like how well it's doing. Because I output stuff as the training goes on. You're probably, well, how did you sneak that in? Well, I'm a Python person, and so I just snuck stuff in some helpers, right? And in the helpers, I wrote some, I forget what it's called, but There's a way to actually intercept functions as they're running and log stuff out. And so when I'm training, I just say main logger and then the epoch logger. And it basically, as it goes, it logs everything as it's happening. And so you get these really cool things. And so the reality of the matter is that and here you can actually see it running, right? In the cloud, which is super cool. And so this is still going. Notice it's getting smarter, right? The accuracy is going up and the loss is going down, which is what you want it to do. But this is really hard to do in a team. And so, as Scott says, governance, this is what lets you have governance. And the cool thing about nowadays with machine learning, people are passing around model files and zip files and stuff. Like if it was 1995, remember before we had source control and stuff? Now you can actually version your models and you can create endpoints with your models. And I made one for food.ai so that we can try this machine learning model as if it was our own service. I've already tested this before. Notice this is a burrito picture.
Is this unique to Azure, Seth? I mean, it seems like what Microsoft has done here, like again, it's all about democratization, yada yada. But wondering, I mean, do you have insight? Is Google doing the same thing with their machine learning or AI type stuff, or is this really like Microsoft?
That's a really good question. I'm sure I couldn't reliably comment on another provider's services. I've looked at them, but I'm going to be biased in whatever I say, and
Sure.
that we're the greatest since sliced bread. Which, incidentally, I learned recently, sliced bread happened after Betty White was born. So literally, the greatest thing that's ever happened is Betty White, and then sliced bread. Just food for thought.
Remember that.
Let's find it. Let's find a picture of some tacos here. Uh, Tacos. Go to some images here. Tacos. Here's a cool thing. Do you know you can do filter and you can license for free to share and use commercially? That's right. So now let's just pick the first one here. So here's a taco picture. Hopefully it doesn't break it. I haven't tested this yet. This is all happening in real time. Oh, look, it guessed tacos, which is awesome. And you're like, well, how did it know? Well, it turns out that when you're writing these things, you also have to give it a score file that says, what do I do if I want to run this model? And it needs two functions, an init to load up the model. And notice that if it's in Azure ML, it gets the model path from the name of the model. Or if it's running locally, it'll just get it here from the outputs, right? And you can see that basically there's some transforms that happen. And then every time it's called, you just run your own custom code to do your own prediction. And in this case, we loaded the model already. I get the image, from the query string. I get the image. I open the image from the content. I transform the image to the right thing, which is what we wanted. And then I pass this transformed image into the Onyx session, right? And then I get the first answer. And that's what I spit out. And that's what the payload is when it responds. And so there's no like mysteryness happening here. Like I can get a picture of another taco. Let's find another taco. Ooh, this one looks like it would be hard. Wish us luck. So put this in here. Oh, good. It predicted tacos, which is fantastic, with 95%. And again, this isn't a real statistic. It's just a soft max over the endpoint. And you're like, well, how did you know it had a soft max? Well, remember, this was an artisanal machine learning model. You can see that I put it in right there. All right, so that is the end of my custom model thing. I'm happy to entertain any questions now,
So,
because that's the end of
Ron,
my spiel, and I didn't want to take too much time. And I
hey,
went fast. Again, there was three things. Again, just to recap: you can use a model, customize a model with Azure services, or you can build your own model with Azure Machine Learning Service. That was the bonus material that I was going to show today. All right, questions.
well, I have a question. This is Ron. Hey, first of all, great presentation, man. That was really entertaining. I really enjoyed that.
And informative.
Yeah, well, that too. But for an AI idiot like me, it doesn't take a lot to impress. But I'm curious professionally, what was your career path to get to where you are doing what you're doing today?
That's a good question. So basically, I lead our developer relations, developer advocate group at Microsoft for AI and machine learning. And so our mission is to help every developer and data scientist be successful with AI in the cloud. And we do that by creating content, helping refine our product, and growing community around it. And so you're probably wondering, well, how do you get into DevRel? That's a good question. My background is kind of weird. I've taught at a high school level and at a college level, so I love teaching. But my training is in machine learning. I went to grad school. I was a doctoral student for a couple of years, got my master's, and then my advisor left. So I'm a college dropout. But I did research in machine learning, particularly in language models, back in the day before deep learning happened. And so I have training in data science, particularly in the mathematical models of machine learning. And so the question is, how did I arrive here? Well, basically, I did some tech work as a developer, right? And then I went and did my grad work, and I was like, what should I study? And then I was like, oh, this machine learning stuff is cool. And so I got into machine learning. And then after that, I got hired as an evangelist at some other place. Didn't use my machine learning as much. Then I moved to something called Microsoft Channel 9. Did some work there. Didn't do much machine learning. I transitioned out of that to do AI and ML again to help with our products for AI and machine learning. And so here I am. So basically, it's a combination of I have a ton of dev experience as a senior dev, building stuff. Like when ASP.NET MVC1 came out, I built an entire application, global application, and I led the efforts there. And then you pair that with like my training is in AI and machine learning. It just seemed like a good fit, and I also love teaching, right? So it was a good fit all together. Does that answer your question?
Yeah, no, it does, and it is. I really like your sense of humor. It's really funny. So thank you.
Thank you. Any other questions?
Are there, so I usually work in the infrastructure identity security space. Are there use cases, arguments, what have you, for integrating Azure Monitor with cognitive services and ML Studio, right?
Yes.
Like in case somebody, leaves a bunch of compute nodes up and running, and for some reason they're still running. Like I want to get alerted on that, or not to stray into odd territory, but like if somebody starts uploading images that for whatever reason I have said, hey, look, in this organization we're not going to allow images of those classification.
Yeah. There's also actually we have something called Anomaly Detector, which is an AI service that you can plug into any data set. I think let me see. I have some secret things here, so let me see. I think I have an instance of it running to show you what that looks like. But I don't remember. Oh, that's the wrong one. So, because there's secret things that I'm still working on. Don't tell anybody. But basically, it's just a service. You point at your data, and it will find anomalies and alert you when their anomalies happen in the future.
Yeah, I'll take a look at it.
It's really cool, but I want to show it to you because I feel like it's only cool if I show it to you. Let me.
That's a great use case, by the way, Scott. So thanks for bringing it up.
Sure. Yeah. Welcome.
I think I deleted it because I was like over. Crap. Oh no! It's here. Did I do it? Did I do it? Yes, I did do it. Here it is. I didn't delete it yet. So basically, let me go here to the web portal, and let me show you the. By the way, these rhinos are pretty cheeky. Look at them. They're like, "What's up?" No, look at them. They're like having a good time. Like this one told this one like a really cool story. Not quite sure if they believe it, and he's like, "Why doesn't Bill ever believe anything I tell him?" You see that? Oh, dang it! Why isn't this working? But basically, I want to show you this. I don't have it ready, but basically, it should. Please work. Something's happening there. But it does. Let me go back to this, and while I put some shredded tacos, metrics advisor, Mike. Metrics advisor, Microsoft. It's really cool because it lets you do a bunch of really interesting things, like show you where the anomalies are coming from. Like you could
Gotcha.
go to root cause of like it's this field and this field and this field are causing the anomalies, and you can look at the anomalies across multiple like areas. You just basically got to put your data into a time series format, and you literally just like point it. And for example, you might reach an anomaly of like, wow, it seems like a user is logging in a lot of times, and you can set up an alert so that it would alert you if something's happening. So
Yeah,
great question.
seems like that strays into almost like Sentinel territory.
I am not as familiar
Right.
with that side of the house, so I must
Yeah.
admit I can't answer that. But
No,
but yeah,
Sure.
Well,
No, thank you.
we've seen that anomaly detection show up in Power BI recently over the last couple of months.
Mm-hmm.
yeah. Basically, these models are well known, and so I don't know why it's not letting me log in, which is a bummer because I have a really cool demo. Oh, and if you want to find a cool demo, Ignite. Ignite. I'll put a link. You can watch this. You can watch this video that I did on Explore on Demand session.
Isn't Ignite coming up soon, or?
Yeah, there's
It
one in
is.
March.
Gotcha.
Did we announce when it was happening? I don't know if we did. But basically here I do a demo. You're not going to hear it. But you'll be able to see fancy, fancy, fancy. Yes, that's me.
Oh.
Here we go. You see that? I go through a demo. That's the one I was trying to show you, where it explains like, here's why you would do it. Here's what the table looks like, right? Here's what's going in, right? Here's the analysis that we're doing. Here's some more like stuff you can learn as you're looking at it, right? It's really quite cool. So yeah, I put the link in there for y'all. Great question. Any other question?
Don't be bashful. Any other questions for Seth?
Yes, hi, Seth. Great presentation. Like pricing. How do you manage pricing or approach pricing? How do you like calculate whether it's worth it and whatnot?
So let me find the pricing page here because there is a way to. So it's basically per call, but you get a certain amount for free. So let's just do the. Here we go. Here we go. So here's an all-in-one cognitive service. Basically, one computer vision, 1 to 1 million. It's $1 for 1,000 transactions. And I think you get like a base free. I don't remember what the base free is though, if I'm being honest. But this is how it's built. How do you monitor that? Well, I've seen customers do a number of things. I've seen the centralization of the services that go through your API to another API to manage costs. But it's basically like $1 per 1,000 transactions. Now, I'll give you an example. Like here, I'll give you a really good example. When it comes to OCR, right, and this is the important part, like you could, like having it read 1,000 different pictures for $1 is very inexpensive. Like you're not going to be able to do that with humans that cheap. And so this is what the pricing looks like for these kinds of things. Now, let's see what else we've got. For custom vision, by the way, there's a tool here to see. Looks like it's free, 5,000 training images, free per project, 10,000 predictions per month, free. 2 transactions per second. The standard uploaded prediction time up to 100 projects, $2 per 1,000 transactions. For training, it's $20 per compute hour, and for storage, it's 0.70 cents per 1,000 images. Does this answer your question? And then you can go through and look at all these other, like Metrics Advisor. Here's another one. Oh, it's preview, so it's for free. Have at it.
So yeah, that's helpful.
There's another example, text analytics, 5,000 free transactions per month. And then the other one, 0 to 500,000 text records, $1 per 1,000 text records. And then look at this. Looks like there's a monthly one, $74 a month, up to 25,000 transactions. And this is cool because sentiment analysis, maybe you're building a Twitter bot that filters out, or a Twitter thing that filters out sentiment on Twitter for your particular brand. You could get up to 25,000 sentiment data points for this much a month, which is actually quite cool.
Is that at a like guaranteed compute tier or?
That I don't know the answer to, but
sure. Sorry.
You'll get these back. If the call isn't coming back in a reasonable amount of time, you should. There's probably an SLA thing. Here it is. There's an uptime.
Yeah.
99%. Yeah. So there's an SLA.
Gotcha. Thank you.
Yeah. Great question. Oh, and here's some tiers. This is more of like a functional tier, not a like compute tier.
Gotcha.
Great question. Any other questions?
Do you see a lot of the times you have to mix and match these different services based on your use case? I mean,
yes.
Do you start like chaining the services? I think I can't remember who was asking, like, is it better to run them in parallel? Do you chain them one after another?
Turns out that in Azure, we have found these things called recipes. And with Azure Cognitive Search, it's one of those tools that builds custom, you can do. So imagine now you build your own, this is basically like build your own search engine for your corporate junk drawer, right? But imagine anytime a document is ingested, you can enrich what is stored in the index based upon AI. Like, let's just say you want to index a bunch of pictures, but then you use computer vision to suck what's labels out of it. So you can search by text. Give me all the images of trees. Like, basically, what it does is injects a bunch of AI, what are called, what are they called? Skills into it, so that when it's ingesting the document tree that comes out, there's a text that's indexed, and then the pictures that are indexed, and then whatever enrichments you do with the skills. So this is a way of chaining a bunch of models together to do a search problem. So we found this pattern happened so much that we basically made a product around it. But the ingenuity around this is how you use them together. That's where you're going to start to get value for whatever it is that you build. So, for example, before I think someone was talking about metrics or anomaly detection. Imagine having anomaly detection that's detecting anomaly around sentiment of things that are coming out of Twitter, right? So now you're chaining a bunch of things together to do intelligent alerts on bad sentiment, right? And you're like, well, we have a 20% tolerance, or in general, the hum we want. There's a hum of bad things that people say, but if there's like an unusual hum, then we can totally detect that with sentiment analysis in conjunction with anomaly detection, right? So those two services that you put together. It's a great question. Any other questions?
Anybody else out there? Still got 11 stragglers.
Cool.
I'm sure everybody's hungry and wanting to get to dinner.
Feel free to hit me up on the tweeters, or just email me. My email is seth.juarez@microsoft.com. And like I said, y'all are just in Portland, which is basically our cool cousins. I'm just north in the Seattle area, not too far. It'd be cool to go to your user group one day for realties.
Please.
You know what I'm saying? but it's just not the time right now. But yeah, any other questions or thoughts before we call this quits? If not, I turn the time over to you, Gregory, unless there's any other questions.
Speak now or forever hold your peace. See, I'm going back to the thank you. I'm getting some thank yous. See some people.
Yeah, I'd just say thanks for this. This has been great. Appreciate it.
How about we give Seth a round of applause? If you all are okay coming off mute and just give Seth, honestly, wholehearted thank you.